Hi guys, so in the last video we were dealing with converting the numbers into base x, right? Try gradually change from elementary mathematics like arithmetic into algebra. And so we're using this x1 machine, and we're using it for polynomial division. Well, we always had a higher order polynomial divided by a lower order polynomial. Let's try something else. Let's try 1 over 1 minus x, right? So let's have this x1 machine have a whole bunch of boxes, right? So for 1, it can be described simply as that because it's only one dot in the one column. And 1 minus x, well, we can rewrite that into negative x plus 1. And so that will have a signature of an antidot next to a dot. So where to go from here? Well, we could use the same method as before, where we're adding in, we're looking at the null space and implicitly adding an antidot and a dot. So let's do that here, right? Ooh, we've got an antidot and a dot pair there. So that means we have 1, 1. Now let's do it again for this. Draw no one here. Well, we might as well keep going, right? We put a dot there, deal with an antidot. There we go. You might see a pattern coming. Well, we're all the way here, and this extends on until infinity, and we just keep on getting the same repeating pattern. So what this would be, would that it's just that 1 over 1 minus x would be 1 plus x squared plus x cubed, or x cubed, plus x to the power 4 plus x to the power 5, and so on. Now we look at this. This can't be, right? It doesn't look like it should happen. But this is something called the geometric sequence, or series, right? Which you might have seen in different textbooks. So let's try to see if it structurally would work, right? So let's take this, and let's multiply both sides by 1 minus x. So that gives 1 equals 1 times 1 minus x plus x times 1 minus x plus x squared times 1 minus x, and so on. Well, let's try to substitute in 2 for this, right? So, dealing with this, we'd have 1 equals 1 times minus 1 plus, what would that be? It would be 2 times 1 minus 2, so that would be 2 minus 4. Let's write this instead of negative 1, let's instead write it as 1 minus 2. That'll make it a lot simpler further down. So we have 2 minus 4 there. Then that would be 4 minus 8 right there. Then it would be 8 minus 16 here. Well, we can look at it here, right? We have this group of 2 and negative 2 here. These cancel out to be 0. So will these. So will these. And it continues on. So then that would suggest that this statement right here is true. Now let's substitute in the original 1. We have 1 minus 2 equals 1 plus 2 plus 4 plus 8 plus 16 plus 32, and so on. So that would mean that negative 1 is the result of this. Doesn't seem correct, right? So we can say that this behaves as this function. However, it is not arithmetically. So what is it then? Well, this is actually a Taylor series for this function right here that we've just developed. Now, you're going to learn about this either in calculus or in university calculus, but think about how we constructed this. We didn't use any Taylor series or any knowledge of Taylor series. We simply used an x1 machine and just drew dots and circles in different boxes. Quite stunning, right? Let's try another one. let's try 1 over 1 minus x squared, right? So we get this right here. Let's make a whole bunch of boxes for us to see what happens. So we have the dot there, and we're looking to divide by, it'll be antidot, antidot, dot for this function right here, right? For an x to 1 machine. Alright, so we can add these to get a group here, so that'll be 1 there. Now we have that there. So let's just add another antidot there and an antidot there, dealing with the dots as we can simply add something without having the consequence occur. So we get another one here, so that's 1. Ooh, but we have 2 dots here. So we're gonna have to make 2 antidots in both of these boxes to deal with these. So you're gonna have this one group here. You're gonna have the second group right here, not including that antidot. So I have 2 there. But we're left with 3 here. Well, then we'd have to make some more antidots on these ones right here. So that resulted in us being able to have 3 there. But now we have 5 dots right here. See, we group these all together, and that's 3. Now we have 5 dots in this one right here. So when we do it there, we should get 5 here, but we're gonna have extra 5 dots and 5 antidots that we canceled, that we group up. Now I have 8 here. So then what we could write that as is, it's gonna be 1 plus x plus 2x squared plus 3x cubed plus 5x to the power 4 plus 8x to the power 5. And look at all these coefficients. What you get is the Fibonacci numbers. Quite a cool way to see how this function will become a Taylor function is through being able to see how it just simply adds up each time in the sum of what's called in the Fibonacci sum. So that's enough for this video today. See you for the next one.